Hello everyone, and welcome to my partial fraction decomposition lesson. Okay, so we have a new problem. This one's a little tougher than the other ones. It's more complex. So, alright, so the first step, we have to first factor the denominator because we have two options usually, either to factor or divide. And you would divide if the fraction is more top heavy, but that's another video. So since we have a stronger root on the bottom, we would factor. So what our factor would look like, we can see that we can factor x squared out from our denominator. So that's what we can do. We can go x squared times x squared minus, it's minus because we have a subtraction sign right here, so minus 2x plus 2, so we can get this. So if we did distribute, it will equal this. So now this is our factored denominator, so I'm going to write that up here. So we basically just turn this into, I'm going to rewrite the numerator. So I will rewrite it minus 8x squared plus 14x minus 4. And then for our factored denominator, this is what we get. So there we go. So this is our first step. What we just did is we factored our denominator from this to this, and I rewrote it. And now we can go into our separating the categories. So what I'll do is I'll write it down here since I'm already running out of space. So the first step, well, the second step is to separate it. So like last time, the other partial fraction decomposition lessons I had, we're going to separate it. So it will be a, b, and instead of c, since we have a more complex term down here, we will have to use cx plus d. So this is what we separate it into. Alright, so we have x squared, which is a repeated factor. So it would have to be x here and then the x squared, because the x squared is repeated factor. So, and then we can write this whole part, this whole thing, excluding the x squared, we can write that right under here. So that'll look like this. Okay, so what we did was we separated our denominator into different parts, and now we have to get the common denominator. So it looks like everything will have to be multiplied by something. So our common denominator will look like this up here. So what this is missing, it's missing an x squared. So we have to multiply it using a special form of 1. We will multiply it by x squared because that's what it's missing. So x squared over x squared. And anything over itself is 1. So that's what we did here. So, and we need to do to a and b. So what x squared is missing, it's missing this whole thing right here. So that would be its own special form of 1. Right? Now let me remove this plus sign because it's a little in the way. So it will be x squared minus 2x plus 2. And then the same thing for its denominator. So this is its own special form of 1. And then for a, what it's missing a lot. So it needs another x so it can become x squared, and then it needs this this whole term right here so it can be equal denominator. So that would be its own special form of 1. So again, I'm gonna move this plus sign so we can have a giant special form of 1 right here. So it needs x times x squared minus 2x plus 2, and then over itself, so it will be its special form of 1. So it looks like this. Alright, so just remember there's a plus sign behind this one. This one is so massive it covers it. So now let me rewrite this to make it look a little cleaner. So it'll look like this. So with all this put in, I'll write it over the same common denominator, which looks like this up here. So this is what it'll look like. And then it's the plus, and that's being hidden. So that's where this came from. It's being hidden up there. B, then multiplied by x squared minus 2x plus 2, and then plus the cx plus d times x squared. So we have this whole thing right here, and this whole massive numerator has a denominator, the common denominator of x squared times x squared minus 2x plus 2. So yeah, that's what we have right now. Okay, so now that we have this whole thing, this massive numerator, we can simplify it. So we multiply everything, so it'll simplify out. So overall, I'll multiply everything together, and then I won't write the denominator because it's the same common denominator, and we're only going to be focusing on the numerator for now. So in total, what everything will look like all multiplied. So we see ax times x squared minus 2x plus 2. That will be right way back here because it's going to be it's going to be a long numerator. So ax cubed minus 2ax squared minus 2ax plus bx squared minus 2bx plus 2b plus cx cubed minus dx squared. So this is the whole thing right up here. See, ax times x squared will also be x cubed minus 2ax squared, and then minus 2ax plus b squared minus 2bx plus 2b cx cubed, and then minus dx squared. Actually, plus dx squared. So yeah, so that's the whole thing. Now that we multiplied everything, all right, we have to now we need to separate it. So like in my last video, I used a table as an example on how to think of it. So we will do that again for here because it's a really easy way to look at it, and it makes a lot of sense. So what we'll do first, we have to use the x to what power of x we're using for our top row for each of the columns. So since it's x cubed, right, it's gonna be x cubed for for the top, and it'll go in descending order. So x cubed, x squared, x, and then the blank. So for the ones that don't have an x, we'll go here. And then we will have our other letter variables, which is the a, b, c, and stuff like that. So what that'll be, it'll look like this: a, b, and then what we used up here, where is it? Right here, cx plus d. That's its own thing. So it'll be cx plus d. So this is what we have so far. Let me fix this up a little bit. And then, so now what we can do is we can sort our long thing right here. We can sort it out into the table. So we have ax cubed minus 2ax squared. I'm just sorting it into wherever it goes. So negative 2ax goes here because it's in the a's. So it's in the a row, and it's in the x column because it has an x. So it will be minus 2ax here, and we don't have any other a's. So now we can move on to b. We leave this blank, so we move on to b. We have bx squared, and we do not have a bx cubed. So for this slot right here, it'll remain empty. So we have bx squared, so that's what we're right here, plus bx squared. It's positive, so I added a plus sign there. Then it will be minus 2bx and plus 2b. So that's what we got here, here, and here. We put it in its spots. So now for cx plus d, we have cx cubed and dx squared. So we will write it cx cubed and plus dx squared, and there is no other x's for cx plus d. And then now down here we will write the numerator. So from the original problem, we will sort this out into our table that we created. So as you can see up there, we will write 8x cubed minus 8x squared plus 14x minus 4. So everything has been categorized and it's in its own spot. So now we can use this. We will simplify this table out to make it more easier to read. So to do that, we have to read downwards, right? So we are reading this table in a downwards fashion like this, like so. Okay, so well, basically, so now since we're at this part, since we already organized the letters to where it's supposed to be, we do not need to look at the x's anymore. We just look at the coefficients and the letters. So what we get a plus c equals 8. I'm spacing them out so it's easier to read and easier for us later. So next we have minus 2a right here, minus 2a plus b, we don't need to put the x squared anymore, plus d equals negative 8. And then we have 2a right here minus 2b equals 14. And then right here we have minus, right here, minus 2b and minus 4. Right here. No, minus 2b equals, sorry, equals negative 4. I thought this was in the C, but no, it equals -4. No, plus 2b. So on obviously we can see that we can simplify this a little better. So we can just simplify it to b equals -2. So this here is now our foundation for our matrix. And what we will be doing, we will be using the coefficients to be determining our matrix. So I will flip to a new sheet of paper and get back to you then. Alright, so now I move to a separate sheet of paper. So now we can create our matrix. So first we look at the coefficients of our little chart here. So now we can create our matrix. So I will do this here. Alright, so since we have A here, right, since it's just A by itself, 1 is its coefficient, so we'll have 1, and then there's no B, so that's a 0. So then it says plus C, which is 1, because it's C by itself, there's no other coefficient, and there's no D, so it'd be 0. And then it equals 8. So for the next one, it will be -2, 1, 0, 1, because right here B, it's 1, there's no C, it's a 0, and 1 because of the D, and it equals -8 from right here. So the next, you can see 2A, oh, whoops, you did not write the A, it's just 2, because we're looking at the coefficient. So 2, -2, 0, 0, 14, then 0, 1, 0, 0, -2. Okay, so this is our final matrix. So if you've seen the other videos, you'd know what to do next, which is our next step is to get this matrix into a reduced row echelon form, which is using the ones, making them run diagonal, and have zeros in all the other remaining slots. So as you can see, this is a pretty big matrix, so it's going to take a lot of work. We already have our first pivot, which is good, so that's a start. So yeah, we are halfway done. Okay, so now our next step from here to our next step is to do a row switch. So what I did, right, I'll write it here. What I did is I row switched our row 2 with row 4, because here row 4, it already had the 1 in the right spot, what we needed for the diagonal, and it had zeros in the other remaining slots, so that was perfect. So that's what I put here. So I replaced it, row 2 and row 4, they swapped, and that's what's here. So next step, we need to get a 0 here, and the best way to go about this is to go downwards, so left to right, but going downwards. So get a 0 here, 0 here, 0 here, then a 1, and then so forth. Because if I would go straight from here or here, you know, I might end up, it might result to changing it later. So it's more beneficial for us to go this way. Even though it seems like a longer process, it's way better in the long run. So we have a lot to do for the next step. So our next step, pencil broke again. So the next step is to we will go here, -2 R1 plus R3. So what this will do, it'll get a 0 here, and we can do 2 steps in one. To save paper, we can go 2R1 plus R4. So basically it's like what was in my other videos, but instead we're putting 2 into 2 steps basically into one matrix. So I will still show the work for what this looks like. So I'll write it right here. So it'll look like this. So first I'll do the first one. So yeah, I'll write it down here. So 2 times R1. So it'll look like this, -2, 0, -2, 0. Then -16, it's -2 times R1. And then plus R3, which is 2. Whoops, it's -2. -2, 0, 0. And then 14. So now we will add them together. Get 0, -2, -2, and 0, and -2. So this will become our row 3. And for right here, so this is what this one was. So now we will be showing the work for this one right here. So 2R1 will be 2, 0, 2, 0, and then 16, and then plus R4, which will look like -2, 1, 0, 1. Okay, and then -8. So we will be adding this together. So will we end up 0, 1, 2, 1, and 8. So now I will write it here as our matrix. So these are basically into one step right here. So that's what I'll write out. So row 1, it stays the same. It'll look like this: 1, 0, 1, 0. And we have 8, right? So then row 2, it also stays the same: 0, 1, 0, 0, -2. And then we will place our new row 3 and new row 4, and we will replace it. So this will be the new ones: 0, -2, -2, 0, -2, then 0, 1, 2, 1, 8. So this is what we have so far, and next we will be doing another step. We'll do it we'll do the same thing, like 2 steps in one, to save a lot of paper because I'm running out of paper. So I will show the work for it. So first, what we're going to be doing is we're going to be taking row 2, we're going to be multiplying that by 2, so R2 times 2, and because we're trying to get this -2 to be 0, so we're going to multiply row 2 times 2 and add it to row 3, so then this will become 0. And the other step will be to negative row 2, so we'll be multiplying it by -1, so this will become -1, and we will add it to row 4, so this will also become a 0. So I'll write that out here so it won't be so confusing. So it'll look like this. So our first step will be 2r2 plus r3, and then negative r2 plus r4. And this will go into our matrix. But first I will show the work. So let me close off the matrix here, and I'll show the work right here. So first, 2 times r2, which will be 0, 2, 0, 0, and then negative 4, negative 2, negative 6, and then 0, negative 2, negative 2, 0. So we're going to be adding. So we got negative 6, 0, negative 2, this is 0, and 0. And this is R3. So from here, we will do the second half of this step, which is negative R2 plus R4. So what this will look like: negative R2. So we're basically just taking row 2, multiplying it by negative 1. So it will be 0, negative 1, 0, 0, and then 2. And then adding it to row 4. So row 4 looks like here, looks like that. So we'll be adding it to that. So 0, 1, 2, 1, 8. So now we will add it. 10, 1, 2, 0, 0. So now that we have both of our answers here, we will be replacing it. We will be replacing row 3 and row 4 again. So row 1 and row 2, they will stay the same. So it will be 1, 0, 1, 0, and then 0, 1, 0, 0. And then now I will replace it, the row 3 and row 4, from what we got. So it'll look like this: 0, 0, negative 2, 0, 0, 0, 2, 1. Okay, and gotta put in our new answer. So A and 2, which is the same, negative 6 and 10 from what we got here. Okay, so we're almost done. We have like 3 more steps to go. So I will flip to a new sheet of paper since I'm running out. So I move to a new sheet of paper, and our next step is to get this a 1 and this a 0 and this is 0. So what we have to do is we can easily make this a 1 by just multiplying by negative 1/2. This will get this to be a positive 1, and this will become 3. So I can write that out. I'll just write that out here. So row 3 times negative 1/2, and I'll rewrite the whole matrix. So same thing: 1, 0, 1, 0, 8. Kind of looks like a 10. I should separate it a little more. 1, 0. Okay, and then row 2 will stay the same. So 0, 1, 0, 0, 2. Then 0, 0, 1, 0, 3, 0, 0, 2, 1, 10. So all we did was multiply row 3 right here by negative 1/2. That's what we got. So now our next step will be it will be our final step actually. So it'll look like this: negative 2 R3 plus R4, then minus row 3 plus R1. So what we're doing, we are going to be multiplying negative 2 to row 3 and then adding row 4 so we can get this a 0, and then we're almost done. We need to get this to be a 0, which would be just subtracting, not subtracting, be multiplying row 3 by negative 1 and then adding it to row 1, and then we're done. So I will still show the work anyways, and it'll look like this. So for first, we'll be doing negative 2 times row 3, so that'll look like this: 0, 0, negative 2, 0, negative 6, so this is negative 2 row 3, and then row 4, we'll be adding it. So row 4 looks like 0, 0, 2, 1, 10. So we'll be getting 4, 1, 0, 0, 0. So this is the new row 4, which will be going right here, right? So now we need to replace row 1 because it has this extra 1 up here. So I'll write this down here. So what we're doing, we're taking negative row 3, so 0, 0, negative 1, 0, and then negative 3, and then we will be adding it to row 1, which is 1, 0, 1, 0, 8. So here, get 5, 1, and then zeros all across. So this will be replaced with row 1. So now I'll write our final matrix, which will look like this. Right, so 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Right, and then our final answer, 5, 2, 3, 4. This is our final answer. Alright, so now referring back a couple pages ago to how it we categorized our stuff. So what it looked like originally was with I'll write it out here instead of going back. It looked like this. So this is what we had it originally, and then now we will be replacing A, B, C, and D with what we have here. So our final answer I will show you in a second after I write out the original problem, which is ax cubed minus 8x squared plus 14x minus 4 all over x to the power of 4 minus 2x cubed plus 2x squared equals, so I'm writing out the denominator, right? So now I will replace it. So 5 goes with A, 2 goes with B, and 3 will replace C, and we'll still keep the x, and then plus 4. So this is our final complete answer. So thank you for watching and sticking through with me to the end. And yeah, this was a long episode, and I hope you enjoyed and watched all the parts of the partial fraction decomposition. lessons that I had. So thank you for sticking with me till the very end, and just want to say thank you. So I'll see you in the next video. Right, later.